All right. Hello, everybody. Thanks for joining me today. I really appreciate you coming out or staying in, as it were, for these things. Well, my name is Trevor, and I'm a student and a teaching assistant here at Launch School. Today, we're going to be talking about how Ruby utilizes variables and explore the concept of mutability as it applies to methods and objects. Specifically, we'll be looking at the idea of variables as pointers and how that influences the behavior of mutating and non-mutating methods in Ruby. So this is really the fifth in a series of recurring Ruby webinars that we're hosting, which are all primarily geared towards students enrolled in the prep portion of the Launch School curriculum. My fellow TA Claire hosted the first three. I hosted the last one, and I'll be hosting this one and then the final one next week. If you're able to make it to some of those previous talks, you should have a really solid foundation from which to understand the information in today's presentation. But even if you haven't seen the other talks, I think that's going to be totally okay. I think even if you're brand new to Ruby, you're going to be able to find this webinar useful. Or that's my hope anyways. So let's just take a look at some of the specific topics we're going to be talking about today. First, we're going to be exploring the role of variables in Ruby. Next, we're going to look at what's actually happening when we assign and kind of reassign variables. Then we're going to look at the concept of mutability with regards to Ruby objects. And then finally, we're going to wrap things up with a discussion between the difference between, discussion about the difference between mutating and non-mutating methods, with the goal really just to become crystal clear about Ruby, what Ruby methods are actually doing behind the scenes and how they work. Now, if you don't have a lot of exposure to these topics, you might think that these are some weird esoteric things to want to talk about, or maybe you just don't really get why you need to care about them at all. And while I think that's reasonable, I actually think these are some of the most foundational and interesting concepts that you're going to be exposed to in the beginning of the Launch School curriculum. Personally, I'm really excited that I get to host this webinar, because I think understanding these topics demystifies a lot of the strange and confusing behaviors in Ruby that even experienced developers find themselves struggling with. So on that note, before we go any further, we actually have a little quiz that I think is going to demonstrate some of these sort of strange and potentially confusing behaviors. I'm going to show you three separate, really simple Ruby programs. And after each one, I'm just going to ask you what you think the output of the program is going to be. I'm just going to put each program up on the screen, and I'll post a multiple choice style question for each program that I'd like you to attempt to answer. Now, please, I think maybe this goes without saying, I don't know, please don't just copy and run the code before you answer. Do your best to think your way through what the answer might be. Your answers are anonymous. You're not being graded on this. It's just a fun way to sort of see where everybody's at. Okay, so without further ado, we have a quick little 3-question quiz here. So here's our first program. Go ahead and look over that while I launch our first question about it. So the question is essentially, what is going to be printed by this program? If that syntax at the bottom is a little bit confusing, you're not familiar with that, all that's going to print is x equals whatever x equals and y equals whatever y equals. There we have about 80% of people who have answered. A couple people lingering out there. If you don't want to answer, I suppose you don't have to, but it's easy enough just to click a button. That way, when we get to 100%, I know everybody's had enough time to think about it and answer. So one person remaining. There we go. Everybody answered. Okay, thank you. All right, I'm going to end this, and we're going to take a look at what people thought. Okay, so we have pretty close to a consensus here. Let's just go ahead and run it and see, make sure everybody's on the same or the right page here. Okay, Right. So about 87% of people, the vast majority of people got this one right. Awesome. We're off to a great start. Let's look at the second question. Okay. Very similar structure here. I just want to know, what is that final line going to print? At the end of the program, what is A assigned to or equaling, and what is Y assigned to and equaling? Or I'm sorry, X and Y, not A, X and Y. One person out there doesn't want to answer. I'll give you another 5 seconds. Perfect. Okay. Okay, I'm going to share the results here. And here we have a little bit more of a spread than the first one, right? We don't really have a clear consensus. We have most people kind of going with that second one. Let's run it and see. Okay, so that's interesting. We have X equals capital A, Y equals lowercase a. That was the most popular answer, but far from unanimous. Okay, let's take a look at this final one, this third one here. If you're unfamiliar with the replace method, it does exactly what it sounds like. It's just going to replace like a given string with the argument. So it's going to replace that A with a B, basically. Okay, just waiting on one final answer, whoever's out there. Perfect. Okay. And let's take a look here. So we have pretty much a split decision here, and then one outlier who thinks, you guys aren't quite right. Let's see, let's run it. Let's see who's looking at this the right way. Where's the CE test? Y equals B, X equals B, Y equals B. That's pretty interesting. And we look at that, it looks almost identical to that. You have very different types of outcomes. Okay. So thanks for participating in that. And like I said, that is some pretty weird, kind of unexpected behavior, or certainly a diverse behavior, depending on how like the code is structured in sort of subtle ways. Pretty weird, pretty unexpected. But I promise, if you hang in there with me, by the end of this workshop, you're going to understand the difference between those 3 programs, and you're going to know why exactly each one of those produced the output that it did. That's my promise to you. So before we get to that, though, we do have a little bit of housekeeping to take care of. First, you're going to notice that during the workshop, I'm going to be switching like back and forth between a slideshow, some live coding using a tool called IRB, and then running some files that I've already written. Unlike some of the previous workshops we've hosted, I don't really think it's necessary for you to type along with me during the coding portions. I think it might actually be distracting to do that. This workshop is a little bit more conceptual in nature than some of the other ones. So I don't want you worrying about the specific methods that I'm using or the specific code that I'm writing. I'd really rather you just focus on understanding the big picture concepts that I'm trying to demonstrate. So feel free to kind of jot down some notes or like sketch out some of the diagrams I've created, or if you want to save time, take some screenshots. But again, try not to get too hung up on like the specifics of the code that I'm writing. Again, just focus on those big picture concepts. And then beyond that, I do invite you to use the Q&A function provided on the Zoom toolbar. If you have a question about anything that I say, or if you need me to clarify something or repeat myself. I really don't want anyone to be left behind here. I don't want anybody to get lost because I wasn't being clear enough. So please just let me know if that happens and we'll clear up anything before we move on. That said, I do ask that if you have any kind of like more general questions or just sort of comments or things that you think can wait until the end of the presentation, I'd really appreciate it if you save those to the Q&A portion. I'm going to stick around and answer everybody's questions at the end. So to not disrupt the flow of things, if you feel like it can wait, please just let it wait to the end. And then also last thing here, if this is your first webinar you've attended with us, just know that you're muted and your video is off by default. I can't see you, I can't hear you, and neither can anybody else. It's just me up here speaking into the void. So you don't have any need to have any like anxiety or paranoia about that. Okay. So unless we have any questions, I think we can probably get started. Great, no questions. Let's get started. So what do variables actually do, right? So in programming, variables are used to label and store pieces of data in a computer's memory. So they're then used to reference those pieces of data throughout a program. And they're typically given sort of long and descriptive names that provide context, which makes our programs easier to read and understand for humans. So variables tend to look something like this, right? So here we have the variable cat that's assigned to the string Oliver. We have the variables cats with an S that's assigned to an array containing several strings. And then we have the variable cat owner that is assigned to a hash containing a couple symbols, a string, an integer, and a Boolean value there. So that's all fine and good, pretty straightforward. You've probably seen stuff that looks like this before. So let's go one level deeper and look at kind of what's happening under the hood here. So I said earlier that variables are used to label and store pieces of data in a computer's memory. This leads a lot of people to imagine something like this, where you have a variable, let's call it X, acting as a container for data. So like maybe X has a string stored inside of it, and then maybe you take X and you assign it to B, so maybe B gets stuffed in there too. And then like, you know, heck, like maybe you can even like stuff another variable inside of a variable. If it's a container, you should be able to, right? If you take anything away from this talk, let it be that this is not how variables work in Ruby. In Ruby, variables act as pointers, which reference single objects in memory. Now, the term object here has a really specific meaning, but for now, I think it's okay if we think of an object as just a piece of data of one specific type. So you can think of like a string or an integer or an array or a Boolean or something like that, right? Importantly, when we say object here, we do not mean methods and we do not mean other variables, okay? So what you see here is kind of a visual representation of how variables work in Ruby. So you can imagine that all of this is just taking place somewhere out in like computer memory land. And on the left, you have variable X, and on the right, you have the string object A. And as you can see, A isn't inside of X. It's not a part of X. It's nothing like that. They're two completely different types of data in the computer's memory. And one, the variable, can be set to reference or point to the object. So then when you have a line of code like this, there are a few things that happen. So first, the variable cat is initialized. Then the string object Oliver is created. And then finally, the variable cat is set to reference or to point to the string object Oliver. All of that takes place with that single line of code right there. So now let's look at variable reassignment. In isolation, variable assignment and reassignment look identical, really. Cat equals Oliver, cat equals Luna. However, because all variables in a program must have unique names, Ruby knows that the cat variable on line 2 is the same cat variable as line 1. So with an example like this, line 1 is really executed the exact same way as it was in the previous example. So our variable is initialized, our object is created somewhere else in computer memory land, and then our variable is set to reference that object. And then, however, on line 2, we already have the variable cat. So all that really happens is that the string object Luna is created, again, somewhere else in computer memory land, and then cat is reassigned to reference that object. So that seems pretty straightforward, but there are some interesting and important things to note here. So first, we have one variable and two objects. Oliver doesn't disappear, or it's not changed into Luna or anything like that. It's still somewhere out there in computer memory land, exactly as it was before line 2 even happened. Second, cat now only references Luna, because every variable in a Ruby program references one and only one object. They can't exist without referencing anything, so they need to reference one object, but they can't reference more than one thing, and they can't reference anything other than objects. Every variable references one and only one object. Okay. So sometimes things can get like a little bit more confusing when you start working with multiple variables. The principles at play don't really change here, but you do have this kind of slightly cryptic syntax on line 2 that you need to be able to interpret appropriately. But first we have line 1, which, as we know, does three things. It initializes our variable, it creates our object, and it assigns our variable to the object, which in this case means that X now references or points to A. So on line 2, the new variable Y is initialized, same way that X was. And while it looks like it's being assigned to X, we already know that variables only reference objects. They can't reference other variables. So what actually happens is that Y is set to reference the same object that X is referencing. Oh, we have a question about that. Okay, so Mike wants to know, why does the first string object still exist in computer memory after reassignment, as it cannot be referred to anymore? So that's actually, there's a lot of depth to the answer to that question that we really can't get into. And that's not the case with all languages. There are things like called garbage collection, where variables, depending on the scope, will disappear. We don't need to worry about that right now, right? Just know that the object isn't destroyed while the program is still executing, right? Once an object is created, it just stays there in Ruby, not the case with all languages. Good question though, Mike, just kind of hard to answer. Okay, so as we see here, X and Y are now pointing to the same exact object. Now, this doesn't mean that X and Y are the same variable, and it doesn't mean that they're aliases for one another. They're two distinct variables that reference the same object in computer memory. Okay, so that brings us back to program 1 here. This is the first program that we kind of looked at. Most people had a pretty good idea of what was going on here, but now we can break it down a little bit more systematically, right? So on line 1 of that program, the variable X was initialized and the string object A was created, and then X is assigned to A. Okay, all that happens on line 1. On line 2, the variable Y is initialized and assigned to the same object that X references, which is also A, so that's all line 2. And then finally, on line 3, the string object B is created and X is reassigned to B. That's how we ended up with the maybe surprising result of X equals B, Y equals A. So before we move on, does anybody have any questions about that sort of pure assignment and reassignment of variables? No? Okay, well, that's great because we got a quiz on it. So let's take a look. Okay, these quizzes are all structured the same way. I'm going to post up a couple little programs, one at a time, and I'm just going to ask you a multiple choice question. What is output here? Okay. So here's our first one under the category of sort of assignment and reassignment. Again, without running this program, just kind of reasoning your way through it. One person out there, you want to answer? Yeah, there we go. Okay. And let's take a look at the results here. All right, pretty close to unanimous here, but let's take a look. Ruby, I think that is called reassignment is what I call that one. Yep. And most people here got the right idea. The reason that 2 is not the correct answer is that because that reassignment of y to 2 occurs after the assignment of z to a. So again, once z is assigned, it's assigned to a value. So this line here says, okay, take z, assign it to the value or the object that y is assigned to right now. So then whatever happens to y after that happens has no effect on z. They're not linked together in any way. Okay. Great. We get another question here. I think we're just going to say, I'm going to call this a flat 60 seconds to answer these questions. And great, just in the nick of time, everybody. Let's post up these results. Okay, not quite a consensus, but most people lean in the same direction. Let's see. Let's run a little bit faster. Okay, so we have that sort of A, B in an array. Let's take a look at why it's not A and 2. We actually didn't cover that in this talk. I talked about this in my last talk, which is about collections in Ruby. But this line 3 here is interpreted as saying, okay, take Z, assign it to an array that contains whatever objects X and Y are currently referencing. So again, X and Y are not actually held in that array. That's a little shorthand syntax. So whatever happens to Y and X later in the program doesn't have any effect after that line 3. Okay, so we have a question about that, actually. Hannah wants to know, are the objects also unique like variables? Let's see. Hannah says, are the objects also unique like variables? E.g., if you have x equals 3, y equals 3, do they both point to the same 3, or are there 2 objects for 3? Hannah, that's an awesome question. We're going to cover that in depth in the next section. There's some complexity there. And the answer is, it depends. And we're going to look at it. We're going to look at why. Okay, Mike wants to know, is the command P equivalent to puts? Is it fine to use it in professional settings, or is it considered less readable? Yeah, there's a difference, what you're going to get with P versus puts. It's not a readability thing. There's some hidden depth behind what's happening with some of these methods, and they call other methods sort of behind the scenes. And P and puts in some contexts are going to have different outputs. This would be one of those examples. If I called puts on an array, you would see both values inside of the array on separate lines. So I did it here just so it was like a little bit more clear. P tends to be a little bit more explicit. Like if you call puts on the value nil, you'll get a blank space. If you call puts, or if you call P on the value nil, you'll get nil. So I use P here because it's a little bit more explicit in the output. Good question. Okay, and we have our final question here. I'm going to stop sharing that. Okay. Last question about assignment and reassignment. Oh, we don't need that. Five seconds, everybody. Got one person out there. I'm gonna give you another second. Let's do it. Let's get an answer in. All right. Okay, we're gonna take a look at the results here. Okay, so we have quite a spread here. Let's run it and see. We get an error. Okay, undefined local variable or method Y. Whew, okay. So what's going on here? We haven't talked about this explicitly. Maybe you could arrive there through some of the things that we talked about. So here, what I'm attempting to do is I initialize a variable X and I set it to the value that Y, the variable references. But I do that before I initialize that variable Y. So that variable Y hasn't been created at this point in the program. So that's where the error comes from. Ruby is reading line by line. Okay, it's different from some other languages who sort of do two passes through. It just goes through one line by line. And it says, okay, line 1, value associated with Y, there's no Y here, error. Interestingly, what if we just did this? That's going to change our answer, right? Isn't it? Why is it not? Suppose I have to assign it to initialize it. That's why. Yeah, in Ruby, you have to assign it to initialize it. Again, unlike some other languages that I was thinking about in my head, sorry about that. You have to assign it as part of the initialization. So that Y doesn't exist until you sort of declare it in your code and then assign it to a value. Okay. Well done, everybody. We're going to clear that out and we're going to move right along here. Okay, so we kind of gave a good handle on that first quiz we looked at. But in order to get the first introductory questions that we looked at, the first program. So in order to understand the other two programs, we need to introduce this idea of mutability here. So in Ruby, some objects are mutable, meaning that they can be changed and modified. Other objects are immutable, meaning that once they're created, they can't be altered. Strings, arrays, and hashes are all considered mutable objects, while numbers, meaning integers and floats, symbols, and Boolean values are all immutable types of objects in Ruby. Mutable objects can be mutated, meaning changed or altered, through the invocation of mutating methods. And so to better understand this sort of concept of mutability, it can be really useful to look at Ruby's object ID method. We do have a question though. Mike wants to know, based on the last case, it means that a variable can only be assigned if it is on the left side of the expression, and using A equals A, the string equals X would not work. That is correct, Mike. The syntax for initializing and assigning a variable, you need to start with it. It goes variable equals object. Okay. Great. So like I said, we're gonna hop into IRB right now and take a look at the object ID method. So for anybody who hasn't used IRB before, it can look a little bit funny, but basically it's a way for me to run a whole bunch of Ruby code without needing to write, save, and execute files, which can be kind of time consuming. So this is just a little prompt here that tells me the version of Ruby that I have and the line that I'm on. You can pretty much ignore that. What you'll see here is I'm going to type in a value and it'll show me the return value. Okay. So the object ID method returns a unique number that represents where that object is stored in your computer's memory. So remember before how I was just kind of saying, yeah, objects are out there somewhere in computer memory land. Object ID can actually tell you where in computer memory land those objects are stored. So what's most important to recognize here is that every unique different object has its own unique object ID, even objects that have equivalent values. Okay, let's take a look at some examples to clear this up. So let's say we have this string object called hello. I'm just going to declare it, and I can call the object ID method on it. And we can see here we get this number. And this is just like a numeric representation of where in the computer's memory that hello string is living, where it's created and where it exists. So let's say I want to create another string. I'm going to call it hello. And what you'll see here is these are similar. They must be close to each other or something, but they're not the same value. So that goes to show me that these two strings, hello, same string, are not actually the same string. They're two different objects out there in the computer's memory. Now, let's tie this in with some variable stuff, right? So let's say we have x equals howdy. Okay, and now I can call object.de on x, which really just calls it on the object that x is referencing. Okay, so we get this number. And then what if I say y equals x? Okay, we get howdy. And then I call object ID on y. What you're going to notice here is that the object ID for x and the object ID for y are the same. Because in this case, again, we have two variables that are just pointing at and referencing the same exact object. It's not the same as creating two different howdies. Okay, so that's pretty interesting. But what we said that some types of objects are mutable and some types are immutable. So what if we do the same experiment with immutable objects like integers, Hannah? We'll notice something kind of surprising maybe. So if two immutable objects have the same value, they're going to have the same object ID. So you said 3, I think. So, okay, well, now we have this integer 3, and we're going to call the object ID on it. Okay, much shorter object ID. I don't quite know why that is, but the object ID of a 3 is 7. Go figure. And then we're just going to say, okay, well, let's create another 3. Call the object ID on that. Oh, 7. Okay. 7. Okay. So unlike those different strings that we had, hello and hello were different, 3, 3, and 3 are all the same. Kind of interesting. So how does this apply to our concept of variables as pointers? So let's say, okay, well, let's say x equals, let's use a different number, right? X equals 5, okay? X dot object ID. Okay, that happens to be object ID 11, right? So let's say y equals 5 now. And we say y dot object ID. And it's the same. Even though I didn't assign y to x, I assigned it directly to a new 5, but it doesn't matter. It ends up pointing at the same 5. Okay, so this means that every time you see the number 3 or 5 in your program, you're using the same 3 or 5, regardless of how many times it appears in your program. It's kind of crazy. You can have this, mathematical equation that's 3 plus 3 times 3 divided by 3. You don't have 3 3s, you have 1 3. It's just being referenced multiple times in the same expression. Kind of interesting. Now, symbols, Booleans, and other immutable objects work the exact same way. So let's take a look at like a Boolean. That's like a true false value. So we have true. Okay, that's, I guess, object ID 20. Let's create a new true. And Ruby just knows to use that same true over and over and over again. We can do the same thing with symbols, which kind of look like strings, but they have a colon in front of them. So let's say it's hello. Okay, and then again, hello. Object ID. Okay, same symbol, same value. If we were to create a different symbol with a different value, we'd need a whole new object for that, and it would have a different object ID. Okay, let me clear my screen here just because it's getting a little bit cluttered. Then we're going to jump in and look at, oh yeah, how do you exit that RB? There you go. Okay. So that's all pretty interesting. This is actually a technique that Ruby, oh, we have a question. We have a couple questions. Mike wants to know, just curious, is the topic of memory management optimization addressed during the Launch School core curriculum? To the best of my recollection, it's not addressed in any significant depth during the Ruby portion, but I do believe it gets addressed in the JavaScript portion because there is a little bit more of like objects or values being created and destroyed depending on where in the program they are. So it becomes a little bit more relevant for JavaScript, and I believe that is covered in the core curriculum there. Nora wants to know, is nil mutable or immutable? Nil is immutable. Good call on that. Nil is a different type of value, so nil is immutable. If we want to verify nil.object, object ID, nil.object ID. Different nils, actually the same nil. Okay, so all of this is really just a technique that Ruby uses to be more efficient. So let's think about this a little bit. Because these objects can't ever be changed or modified, there's really no reason to create a new one every time it appears in your program. All your program really cares about is like an object's value. That's all that really matters to the execution. So it just uses the same immutable object that it already created. It's already there, so we're just going to use that. The value of an immutable object can never change. A 3 is always going to be a 3. So why would I ever need to create more than one 3? I can just reference the same one over and over again. Mutable objects need to be unique, though, because their values can actually change throughout your program. So this is accomplished through the use of mutating methods. So let's take a look at that. So again, we're just going to have this variable x. We're going to assign it to a string, which is a mutable object type. We're going to call x dot object ID, which is going to tell us the object ID of that a, big long number, fine. But then what if we call a mutating, that's not mutating, mutating method on our object here. Okay, so now we see the value has changed. Does everybody recognize that? So now when I reference an x, I don't get a little a, I get a big uppercase A. But then if I check the object ID of that big uppercase A, it's actually the same. So now we have that same string object, not a new one, but the value has changed. Okay, so this is distinct from the behavior of what are known as non-mutating methods, which typically return a brand new object instead of modifying the object which called it. So we're going to start all over again. We're going to go x equals little a. Okay, so we have our little a again. X dot object ID. Okay, we get some number. It's different from that other little a we created, but there's our number. We're going to call X dot upcase, no exclamation point this time. It's going to return a big A. But if I check my X, we still have our little a there. That other big A is somewhere else. And then if I check my object ID on my little a, it is still the same. So the A isn't changed. The object isn't different. X didn't get reassigned, nothing like that. All that non-mutating method did was return a new object somewhere else. Now, there's things I can do with that. I could pass that to an argument. I could maybe call a method on that. I could maybe capture that by assigning it to a variable. I didn't happen to do anything, so it just got created. And like Mike sort of alluded to before, it just sort of exists there now. I can't really get to it anyway, but it's still there. Okay, let's hop back into our slides here. Okay. So we talked about mutating and non-mutating methods. Here's a little refresher about some of that stuff that we covered, because it can be a little bit mind-bending, all right? So some methods mutate their caller or their arguments, while others do not. Okay. In general, methods either have a meaningful return value. Oh, I'm sorry. While the names of some mutating methods end with an exclamation point, like upcase, gsub, etc. This is really just a naming convention and cannot be relied upon. Oops. So in order to know if a method mutates its caller, you need to check the documentation or experiment in IRB. Looks like what's missing from my slide here is this idea that methods usually either have a meaningful return value. So that's what we were talking about, that upcase without an exclamation point, it returned a big A that I could have done something with. Or they kind of have methods can have a side effect, like mutating the object it was called upon. So that's usually the difference. Non-mutating methods almost always have a meaningful return value, and mutating methods always will change the object that they were called upon or passed as an argument. Okay. But before we can look even more closely at how mutating and non-mutating methods are used, it's really important to talk about method invocations and return values. So this might be a refresher for some of you, depending on where you are in the course, but it is really important stuff that clears up a lot of the fuzziness with some of the examples we're going to look at. Okay, so method invocations. Let's talk about what's a method invocation. Okay, so methods can be invoked on objects. They're not they cannot be invoked on variables or other methods. The object that the method is invoked upon is often called the calling object. So if you hear that term calling object, it's just the object that the method is invoked upon. Visually, what that looks like with methods that are in the Ruby standard library, it's the thing before the dot and the method name. That's the calling object. Okay, so some methods can be invoked with arguments, which are additional pieces of data that influence what the method does. And only objects can be passed to methods as arguments, not variables or other methods. That's important. So if we look at this kind of simple looking code here, this code is invoking the upcase method on the object referenced by X. It is equivalent to a.upcase, meaning it is not, you're not actually calling upcase on X. You're calling it on the object referenced by X. This code is invoking the replace method on the object A and passing in the object referenced by X as an argument. It's equivalent to a.replace B. Okay, so it's just objects and references all the way down. Okay, so all methods have a return value, which itself is an object. It can be a string, an integer, an array. It's not some special object. It's one of the ones you know about. Usually, but not always, non-mutating methods have like a meaningful return value that's meant to be used in some sort of way, while mutating methods also have return values, because all methods do. Sometimes they're meaningful and other times they're not. So they're a little bit fuzzier there. Variables can be assigned to the return values of methods. And in order to know a method's return value, you just need to check the documentation or experiment in IRB. That's the only way to know. Okay, so this code is actually assigning the return value of invoking the upcase method on the string object A to the variable X. So it's taking X and assigning it to the return value of A.upcase. Okay. That was a lot. Let's look at it in practice, shall we? So if we want to walk through what happens when we use a non-mutating method, we can use this straightforward example right here. So on line 1, we have the same exact thing we've seen in all of our previous examples. We initialize variable X, we create an object A, and we assign or point X to A. But then on line 2, things kind of get interesting. First, we invoke the upcase method on the object A. I'm sure that's what it looks like in the computer. I know it looks like the syntax there looks like upcase is being invoked on X, but methods are only invoked on objects, not on variables. So it's actually being invoked on that A. That's why it's on our A side of the screen here. Then upcase sort of like does its magic, and because it's a non-mutating method, it returns a new object. Or do you get that? You invoke that on A, and it just returns this new big A somewhere else in the computer's memory, which in this case is the string with a value of capital A. That's just the way that upcase is defined. So the final thing that happens on line 2 is that X is reassigned to that new string object. Okay, so that's non-mutating methods. Everybody feel pretty comfortable about that before we get into the non-mutating method quiz? Okay, well, let's get into the non-mutating method quiz. And that's reassignment. Okay, here's question number 1. I'm gonna post up. Oops, that's 2. That's 2. Sorry. Don't look at that. Sorry. Where's my non-mutating one? Okay, here we go. Give it a couple extra seconds here because I threw up the wrong quiz question. So the last person, we have one person out there. In the next 5 seconds, if you want to, take a stab at the answer. 4, 3, 2. Okay, I gotta end the quiz because good, we just got in. Perfect. Okay, let's share the results. All right, close to a consensus, not quite unanimous. Let's see though. I'll get Ruby, or where am I? Non-mutating. Non-mutating 1. Okay, we get a capital A. Just so we can clarify exactly why that is, I'm glad that we had so many people get that answer right, but let's look at it really quick. Essentially what happens on line 1, we have X pointing to a little a. On line 2, we create a Y, we create a big A, and we point that Y to the big A. The relevant part here is line 3, where now we take that X that already exists, and we stop it from pointing at little a, and we point it to what Y was referencing, which is that big A. So line 3 is our relevant line there. Okay, well done, everybody. Let's take a look at the next one, which you might have had a sneak peek of. Yes, that is 2. This one's fun. We get to look at the object IDs. Again, if the syntax is a little bit unfamiliar with you, or you're a little unfamiliar, it's unfamiliar to you, I think is the phrasing. This is just checking, are these two things the same? So if X and Y are referencing the same object, this will print true. Otherwise, it'll print false. Or if I did something crazy in here I'm not allowed to do, it'll throw an error. Last person, 5 seconds, 3. Perfect. Okay. Let's look at these results. Okay. Most people are going with false, few people going with true. Let's see what we got here. Okay, we have false. Let's talk about why that is really quick, just so everybody's on the same page here. We have X, we assign it to 3. Incidentally, this 3 is the same 3. We only have the 1, 3 that we use now. So then we take Y and we assign it to the return value. This is actually a method, interestingly. So this is your calling object. Here's your argument. You don't need to know that yet. You'll learn it later. But essentially what you get is now Y is assigned to this 15 that's created somewhere else. What I think tripped some people up here was that this Z equals Y divided by 5. I think some people thought, oh, well, if I multiplied this up here, well, maybe my Y, the value is being changed with this division. But remember, because this is really just a method, this division sign. So what's happening is that the value that Y points to, which is 15, is used as part of that method invocation. The Y is really not involved, even though it looks like it. Okay. Final one in this non-mutating section. So a few things to explain here. This is going to print 3 values. They're not going to look like they're not going to be printed on the same line, but there's no way to structure the answer to the question any different. And then additionally, you might see this. This means toSym. This is the toSym method, and it returns the symbol version of a string that calls it. Give everybody a few extra seconds here. It seems like people are really thinking their way through this one. It's a little bit trickier than the previous ones. Five more seconds for 2 people left out there. And perfect. Okay. Let's take a look. So much more of a spread here. Let's see what the answer actually is. We have a false, a true, and a true, which is the most popular answer, but far from unanimous. So let's talk our way through it. Okay. So this first one, let's go line by line, shall we? We have X, we assign it to an object, string object. We have Y, we assign it to a different string object. They have the same value, but they're 2 different objects. So that's why we get our first false on this line. This is basically saying our X and Y are the same object, and they're not, even though those 2 objects have the same value. Interesting. Z equals X. So now we have this new variable being initialized, and it is being assigned to the same string that X is pointing to. So that's where that true comes from, incidentally, because that Z, this syntax on line 6 means, give me a Z and make it point to or reference that same object, whatever it is that X is referencing. Cool. That's where that true comes from. And then we have this interesting bit here. Now, this is the tricky part, because we're taking X and we're assigning it to the symbol version of hello. So we looked at this, actually. It's that colon hello. And we're taking Y and we're assigning it to the symbol version of hello, which again is that colon hello. Now, what's relevant here is that symbols are immutable. So this line 12 creates this symbol with a value of colon hello, and Y says, oh, I'm going to go ahead and assign to that too. Because again, with immutable values, or with immutable objects, if the value is the same, the object is the same. So that's how you get this final true here, is that these oddly, even though the syntax doesn't look like it, end up referencing the same object because we're dealing with immutable objects here. Awesome job, everybody. We're going to cover mutating methods here really quick. I know we're butting up against our time limit. I'm going to get through it, but I think this stuff is really important. So, okay, working with mutating methods. So now, our first line of this type of example is the same. So we're just going to skip that explanation. That's what happens. Okay. Now, on line 2, you see that our string object A invokes the mutating method uppercase with an exclamation point. What that does is it mutates our existing object, so the value is now capital A. So that's what happens there. Perfect. No new objects was created, or no new objects are created, and no reassignment happens on that line. The object itself was just changed. Okay. So that brings us back to program number 2. If you remember that one, that was a while ago, but here we are. Okay. So we looked at it in the beginning. Well, let's walk through it line by line now. On line 1, variable X is initialized, string object A is created, and X is assigned to A. A is created, X is assigned to A, perfect. On line 2, variable Y is initialized and assigned to the object that X references, which in this case is our A. On line 3, the non-mutating method capitalize is invoked upon the object referenced by Y, that's our A. Capitalize does its magic, and a new string object with a value of capital A is created. Again, just somewhere else in computer memory land. But also on line 3, variable X is reassigned to the return value of calling capitalize on the object referenced by Y, which in this case is capital A. So that's how we ended up with X equals capital A, Y equals lowercase a. Okay, and then finally, program 3, that tricked a bunch of people up. Let's walk through this one line by line. On line 1, variable X is initialized, string object A is created, and X is assigned to A. Same as every other program we've looked at so far. On line 2, a variable Y is initialized and assigned to the object that X references, which in this case is A. On line 3, the mutating method replace, notice mutating method replace is invoked upon the object referenced by Y and pass the argument B. Replace does its magic, and our existing string value has its value changed, or our existing string object has its value changed from A to B. Also on line 3, variable X is reassigned to the return value of calling replace B on the object, which in this case is a pointless reassignment because X was already referencing that object. So it turns out that replace modifies the string and returns it. So that reassignment didn't really need to happen. It was kind of there to just throw you off. Okay, so that's why this program ended up outputting X is B, Y equals B. If you have time to stick around, I have one last quiz for you, 3 more questions. If you don't have time, please grab this. I'm going to post up in the chat here a link to a feedback form. I really appreciate everybody's feedback. It'll take you less than 3 minutes to fill it out. So if you want to fill that out, that's awesome. Stick around for the quiz though, if you can. Here's the quiz. Okay, first question. The hint here is that all 3 of these questions deal with mutating methods. We have a battle going on with the answers here, everybody. Last person, 5 seconds. Here we go. All right. Excellent, everybody. Okay. We got a 10-5 decision here. Let's see. It's false. Let's talk about why it's false. So the array.pop method, so the .pop method, you can call it on an array, and what it does is it removes the last value in an array and it returns it. So X is being assigned to the return value of calling pop on our array here. So X is going to actually be referencing a 4, and array has been mutated, so that 4 is gone. So array equals an array containing 1, 2, and 3, and X equals 4, which are not the same thing. That's why you get false. Okay. We're going to take a look at a little bit trickier one, I think. I have a little comment here. We've seen this, but the upcase method essentially mutates the calling string to an upcase version of it. We're going to a few extra seconds here. 2 people left. Let's give it another. Oh, 1 person left. 5 seconds. Everybody's done. Okay. Great job. Okay, let's take a look. Okay, split decision here. We have an 8, 3, 3, and 1. Let's run it and see what we got. Okay, true, false. Most popular answer, but far from unanimous. So let's go ahead and walk through what's happening here. This one is admittedly tricky. Okay, so few things at play here. We're really consolidating some of the concepts we looked at. So here, X and X returns a reference to the same string out there in memory. Hello. What's the object of it? The object ID of that object before and after it's mutated, the object ID doesn't change. The value changes, but the object ID does not. Okay, so it's the same string, just has a different value after you call upcase on it. It's all capitalized. Okay, so that's why that is true, because you're dealing with the same string before and after mutation. This part is trickier. Hello and hello look like the same string, but we actually use this example when we were looking at object ID. And hello, every time you declare what's called an object literal, where you just sort of like type out that string hello, you're creating a string literal, you create a new object. Because each one is mutable, it has the possibility of changing throughout your program. You can call mutating methods on it. So it's not safe to reuse it. So even if we got rid of this line where we mutated, and now we have hello.objectID equals hello.objectID, that doesn't even change our result because they were never the same object. Okay, final quiz question. You guys have hung in there really well. I really appreciate it. Here we go. A little bit of like a mind-bending assortment of options here. 2 people left. Let's give ourselves 10 seconds. One person left, 5 seconds. All right, I gotta call it. You want to get an answer in? All right. All right, here's what we got. We ended on a split decision. So let's run it and see where we're at. The triple uppercase A's take it. Let's talk about why. Line by line. Line number 1, we initialize variable X. We create a lowercase a. We take X. We just create a pointer from X to A. All that happens on line 1. Line 2, we initialize Y. Now we have another variable over here. We take it and we create a pointer to that same A that X is referencing. Okay. Line 3, a lot of stuff happens. We call capitalize uppercase on Y. What capitalize does is it takes that A and it makes it big, makes it capitalized, and it returns it. And Z gets assigned to that. So in this instance, we have 3 variables all pointing to the newly mutated uppercase A. They're all pointing at the same object. That's why they're all uppercase A. All right. We did it, everybody. A couple minutes overtime, but that's all right. I'm going to stick around here for questions. If anybody has questions about this material or other material that maybe I can answer, hopefully, maybe questions about launch school, anything like that. So I'm going to stick around for a few minutes. If you have any questions, I'm here. If you are ready to take off, please, I request that you go into the chat and you fill out that feedback form. I appreciate all the feedback. I use that to sort of alter and change these each iteration through. So, okay. Lyra wants to know. Thanks, Anonymous. Lyra wants to know, why would I ever need 2 different hello values as strings? Hello in quotes. Great question. Let's look at it. Let's figure this out. So let's say I have an X that's equal to hello. Right. And then I have a Y that is equal to hello. Right. But then I want to do something to my X value. Let's say I want to make it uppercase. And because I can mutate strings, I have that option. If you can't mutate an object, your only option is to reassign that variable to another object, which is not going to have any other impact, any impact on any of the other variables that happen to be pointing to it. So now I say x.upcase. So now I have a big hello. But what does my Y equal? It still equals little hello. Okay, because I have 2 hello objects. Those objects for mutable values like strings and arrays and hashes, the value can change throughout your program because they're mutable. That's what mutable means. So if you happen to have 2 or 3 variables all referencing that same value when you don't want it to, you make a change to one of them, you just change the one that X is pointing to. Well, now you've changed the one that Y is pointing to, the one that Z is pointing to, because you only have one. And it can really mess with your program. So with mutable values, you need to be able to have more than one. Immutable values, doesn't matter. The value can never change. So does that clear that up? We have any other questions? Oh yeah, it does clear it up. Awesome. Any other questions, anybody? Happy to stick around, but also happy not to stick around if you don't want me to. So. Well, looks like that's it, everybody. Please fill out the feedback form. I appreciate it. I'll see you next week. I think I'm doing what, problem solving and debugging. That's a really fun one, super interactive. It gets a little bit chaotic sometimes. So maybe you'll join me for that. Everybody have a good evening or a good day, etc. And take care.